Hi guys, welcome to the video on the properties of parallelograms. So we are going to learn about the properties of a parallelogram and how to apply them. Engineers use parallelograms to construct houses and buildings, and that's why we're learning this. And you know you're successful when you can find the missing diagonal, side length, or angle within a parallelogram. So, at any time during this video, guys, feel free to pause in order to write down some of the properties. I'm not going to spend a whole bunch of time on each property page, so you probably will need to pause in order to write them down. Alright, so first we're going to start with the definition of a parallelogram. It's a flat shape with opposite sides that are parallel. And it is a flat four-sided shape. So being very specific, it has to be four-sided, which makes it a quadrilateral. So it is a quadrilateral, a flat four-sided shape with opposite sides that are parallel. The first property of parallelograms is that the opposite angles of a parallelogram are congruent to one another. So as you can see from my diagram, angle A is congruent to angle C, and angle D is congruent to angle B. The second property is that any two consecutive angles, so consecutive angles just like in trapezoids, well, now they apply to any two angles that are next to each other. Any two angles next to each other sum to 180 degrees. So in this case, angle 1 plus angle 2 is 180, and angle 2 and angle 3 added together is also 180. The third property of parallelograms states that the opposite sides of a parallelogram are congruent, so the ones that are directly across from one another. So in this diagram, side AB is congruent to side BC, and side AB is congruent to side CD as well. And finally, the diagonals of a parallelogram bisect each other, meaning they cut each other into two equal parts. So, in addition, they create some congruent angles. So you can see between this triangle 3 and this triangle 4, those angles are congruent. And in triangle 1 and triangle 2, those angles are congruent. And the diagonals of a parallelogram not only bisect each other, but also create a bunch of smaller and congruent angles. So 3 and 4 are congruent, and 1 and 2 are congruent, because they have congruent sides and congruent angles, and they could all be proven congruent through SAS. But mainly we are certain that AE, the midpoint, A to E, is congruent to CE because it is cut in half by point E, and DE is congruent to BE because that's diagonal 2, and that is also congruent. BD is split in half like AC is split in half. So, examples. The shape below is known to be a parallelogram. What are the measures of its missing angles? So, I know that these two angles are congruent, so I do know that angle B is 55 degrees. And I knew that because that is the second property of parallelograms that states that the opposite angles are congruent. No, that is the first property, excuse me. The second one states that these two angles here are supplementary. So to calculate A, I could do 180 minus 55, which is 125 degrees. And then B and C are also supplementary. So angle C would be the same thing. It would be legitimately the same exact. I wanted to just copy paste, but it's not going to work. It would legitimately be the exact same process of 180 minus 55 leaves me with 125 degrees. So, find the value of x in the parallelogram and use it to find the measures of angles B and C. So if I was looking to find, so this would be like side A, and then this would be like side D, or point D. I know that these two angles that are across from each other are congruent. So angle A is congruent to angle D. And because they are congruent, I can make substitutions. X plus 25 is equal to 3x minus 45, since I can substitute equivalent expressions. And then I'm going to go ahead and subtract subtract an x from both sides to get 2x over here equals, and I'm going to add 45 to both sides. So add 45. I'm going to just write it in here. Add 45, add 45. I took an x away, I took an x away. So I get 2x, and on this side, I'm going to get 70. So x is equal to 35 when I divide by 2. So divide both sides by 2. And then I can substitute those values in here and here in order to calculate their measurement. So if I do that up at the top, A or D, either or, when I substitute a 35 in, I'm going to get 60 degrees. And then if this is 60, one of the properties that we learned, the second property, tells us that these two angles add up to 180. So they add to 180 degrees. So C has to be 120 degrees, and so does B, for the exact same reason. Okay, the shape below is known to be a parallelogram. What are the values of x and y? So if I know that to be true, one of the properties of parallelograms states that the opposite sides are congruent. So I know that these two sides are congruent. And then I'm going to draw all the way across. These two sides are also congruent. So if sides are congruent, I can write their equivalent expressions as being equal to each other. So I'm going to do my x's over here. 3x minus 12 equals 6x minus 72. And then along a similar lines, I can also say that 6y plus 8 equals 3y plus 32. And then I can start going ahead and subtract, solving for either one. I'm going to start with the y's. Take 8 away from both sides. And then subtract 3y from both sides. So 6y minus 3y is still 3y. 32, the y's cancel over here, and then the 32 minus 8 is 24. So dividing by 3, y equals 8. So I have solved for y. And then if I'm going to solve for x, I'm going to do so in the same way. I'm going to take 3x from both sides. And then because I've got the x on the other side, I've got to add 72 to both sides. So when I do that, I get 60 on the left side, and I get 3x on the right side. So dividing by 3, x equals 20. And that's it. So I've got my two values for x and y. So the shape below is known to be a parallelogram. Find the measures of the diagonals AC and BD. Okay, so this one's kind of complicated. All I have for the measures of anything here are two expressions that go from A to E and then E to C, and then I have two expressions that go D to E and E to B. What I am very, very fortunate for is that I can solve for these missing variables by using the properties that the diagonals cut themselves in half. So I know that this diagonal is congruent to this diagonal. And then this diagonal here is congruent to that diagonal there. So I'm going to just draw some arrows between them. Those two diagonals are congruent, and these two halves and those two halves are congruent. So because they are, okay, I know that AE is congruent to EC. That is a property. And then I can write an equivalent equation using the two expressions. So AE is measured to be 2x plus 7, and EC is measured to be negative x plus 8. So because they are congruent, now they're equivalent in equation form, and I can solve for x. So add x to both sides, and then subtract 7. And I end up with 3x equals 1. And so if I go ahead and divide, I get x equals 1/3. And then I can solve the y's doing the same thing. So the y's, I know that DE is congruent to BE. So I can write an equivalent expression. That's 7y minus 56 equals 4y plus 17. So I'll take 4y from both sides and then add 56 to both sides. So over here I get 3y. And then on the other side I get, so 17 plus 56 gives me 60, 73. And then if I divide both sides by 3, I am going to get, it looks like I am going to get 24.3 repeating. So, and over here, this 1/3, we'd write that as 0.3 repeating. So then what I can do is substitute those values into my expression, and then that would tell me the measure of the diagonals. So for y, if I were to substitute y into the equation, okay, of 7y, so 7 times 24.3 repeating, that's a 2, and then take away 56 from it, that'll tell me what that is. So let's go ahead and do that. So 7 times 24.3 repeating minus 56 gives me 114.3 repeating, which means that is half the measure. So this is equal to DE. I know that DB is equal to, my writing got a little sloppy there. DB, switch back to the pen, is equal to that times 2. And so multiplied by 2 would be 228.6 repeating. And then if we do the same thing over here, the numbers work out a little funky on this one, guys, but just bear with me. You're going to get x, or you substitute that value in, and you're going to get 7.66 for AE, and AC is going to be equal to double that. So AC would be 7.66 times 2 is actually, it's 15.67 or 333 repeating. So that's it, guys. Parallelograms are closed, four-sided shapes with two pairs of parallel sides. They have four main properties dealing with their sides, angles, and diagonals, and then we use those properties to make assumptions and complete our calculations. Thanks for watching, guys. I'll see you in the next video.